on the surface. On the surface of the moon. The moon if its radius of the S if its radius is if its radius is 1/4, if its radius is 1/4, of what? 1/4 of the radius of the S. Of the radius of the S. 1/4 of the radius of the S. And the mass is 1/8 of the mass of the S. It's 1/80. Mass is 1/8 of the mass of the S. The mass of the S. Yeah. So this is a quiz also. I'd like to ask you that to pause the video, do that quiz, and then come back to the correction. What will be the acceleration gravity on the surface of the moon if its radius is 1/4 of the radius of the S and its mass is 1/8 of the mass of the S? So that's the question. Please make sure that you do it faithfully, write your level best, do it and give me the accurate response. So keep on doing, suppose keep on doing, then we'll carry it on. Yeah. Okay, so let us solve. I think that you have got enough time to do that quiz, to test yourself. But one thing which I want to make clear, whenever you'll be given, say, physics questions or a chemistry questions, please try your level best to think in different ways how you can use the given data. Don't use constant values because they are constant values. For instance, for these questions, the value of gravitational constant is not given. The value of radius of the S is not given. So if in case that you want to solve this problem by using the concept that maybe a body is revolving around the moon, and then you use maybe to find, just like what you have derived at the beginnings of this lecture, that maybe you find acceleration gravity, and then you think it means you plug the value of universal gravitational constant radius of the S. That is completely wrong, because you won't use these values, right? So be careful on that. We know that these are the constant, but you use them in case you have been given. For example, if maybe you are looking for the, let's say, density of the S, let's say. So density of the S, you know that is mass of the S, density over 4/3 pi r of the S cubic. In case you have been given mass and density, you have been given mass, but radius of the S, is not given. However that you know, you should leave the letter radius of the S, and then you comment that RE is not given. So be careful on that. So because it is a quiz, I can do the correction in this lecture, so you can check yourself whether you are right or you're not right. Okay. So first of all, the primary means the first step that you have to remember. The first step on solving physics problems or chemistry problems is data given. Data given. So in this data given, you say that what will be the acceleration gravity. So first of all, acceleration due to gravity means G. This is required. Okay, is gravity of the surface on the surface of the moon. So I think that on the surface, acceleration due to gravity on what? On surface of what? Of moon is what is required, not on the surface of the earth. But when you'll be finding the acceleration gravity on the surface of the moon, you have been given that its radius is 1/4 of the radius of the earth, and its mass is 1/8 of the radius of the earth. So the second given is that we have to let RE to be radius of 40, radius of earth. Okay, and then let ME to be mass of 40, mass of the earth. Mass of the earth. So therefore we say radius of the moon, and this radius of the moon we can call it R of the M, Rm. This is equal to 1/4 radius of the earth. Right? And then mass of the moon, which called M subscript of M, is equal to 1/8 of 40 mass of the earth. Right? So those are the relevant that will be given. Let us go to the second step. The second step now, let us consider a body. Means that the body of mass M, let us consider the body of mass M, consider a body of mass M revolving what? The S. So we have to sketch to present the orbit and the S as the center of the system. So then now we have our cycle. Excuse me. This the orbit, circular orbit, and then this the S. Again, this the body of mass M, and this the S with mass of the S, and here we have a distance called radius of the S, and suppose that this body is moving in this direction. So this is the orbit, and that the body revolves around the S, okay, on the surface of the S. So we say that the steady state we have to recall Newton universal gravitational law. The long term says Newton universal gravitational law. So how does it say? We say that the force of attractions on the Earth's surface, force of attractions on the Earth, this is equal to it. Mass of the body, gravitational constant, mass of the Earth over radius of the Earth, then what? Square. So this is the first equation. So again we go for the first step. The first step we say that consider the body of mass M revolving the moon. Right? So again we say that we have another orbit. This is the moon at the center. Okay. Suppose that here we have a certain body, let's say of mass m. Right? Mass m. Okay, again here we have to take considerations that before just we go further, it means that after having this, we should also say that the weight of this body, mg, but g on the s, should be equal to the force of acceleration. So this will be the first equation, the second equation after this one. You have to write this downwards after this, right? And then we say that we have the moon with mass m, and then here we have radius of the moon. Okay, then here we have mass of the moon, m, and this is the orbit. So we say that under this case, we say that the gravitational force, the force of attraction, it will be gravitational force, mass of the moon, mass of the body, over radius of the moon square. Right? So then this is what equation 3. Again we say that weight of this body, mg, is equal to force of attraction, but on the moon surface. And this one on the moon surface. So if that's the case, we say that this is question 4. So if that's the case, we say that we go for the fifth state. We say that equate equation 1 and 2. Then we have to equate equation 3 and equation 4. Right? So the equation 1 and equation 3, so that mg on the s surface is equal to mass of the body, mass of the s, gravitational constant, radius of the s square. So mass and mass cancel. So if that's the case, you say that gravity on the S is equal to what? Is equal to mass of the S times acceleration gravity g of what? Radius of the S square. So then this is equation 5, right? And then so we say that we have to equate again mass of the body and acceleration gravity on the moon, right? G on the moon, this one. G on the moon, this one. What is the G of the moon? Yes, this is G on the moon, on the surface of the moon. So this acceleration gravity on the surface of the moon. We have mass of the body, mass of the moon, times gravitational constant, radius of the moon square. So mass of the body, they cancel. So gravitational constant of the moon surface is equal to mass of the moon, gravitational constant, radius of the moon square, and this is equation 6. Right? I think that you still enjoy it, but I don't know if you have got it. Then the question was asking us to find the gravitational constant, the acceleration gravity on the surface of the moon. So for that case, now we got the sixth step. The sixth step, we say that let us take equation 6. Equation 6 divided by equation 5. Why should we divide? Because we don't know the value of mass of the, we know the relationship between mass of the moons and mass of the Earth, but the value of gravitational constant is not known. So you have to eliminate it. Or in other words, you can make the universal gravitational constant the subject in this equation, and then you come with the subject, substitute them. Right? So then we say that acceleration gravity on the moon surface of acceleration gravity on the Earth surface, this is equal to what? Is equal to the mass of the moon times gravitational constant, universal gravitational constant, radius of the moon square. Then this one we divide with mass of the S, gravitational constant, then radius of the S squared. So if that's the case, you say that acceleration of gravity of the moon, the S, is equal to what? Is equal to mass of the moon, gravitational constant, radius of the S squared, divided by mass of the S, gravitational constant, radius of the moon square. So universal gravitational constant, universal gravitational constant cancel. So for that case, we say that mass of the moon over mass of the S, and then see what radius of the S over radius of the moon, then what square. So for that case, you say that acceleration due to the gravity on the moon surface to be mass of the moon, mass of the S. Then we say that the radius of the S surface, radius of the moon surface is square times OT, acceleration gravity or the OT on the S surface. Okay? So if that's the case, you say the acceleration gravity on the moon surface is equal to what? Is equal to mass of the moon. What was the mass of the moon? Mass of the moon was 1/8 mass of the S. So divided by what? Mass of the S. So this is the seventh step. Seventh step, we say that we are computing now. And then see what radius of the S as numerator, and then radius of the moon, it was 1/6 radius of the S, but the square times gravitational constant of the S. Right? So mass of the moon cancel, radius of the S cancel, acceleration gravity on the moon surface, it will be 1/8, and then we say that multiply by 6 square G of the S. So acceleration gravity on the moon surface will be set as 6/8 gravitational, or it means that G on the S surface. So this is equal to set as 6/8 times 9.8 meter per second square. So G on the moon is equal to So if you do your computation, it is 1/4, I'm sorry. This is 1/4 RA. I made a mistake. So this is 4, it will be squared. 4 times 4, which is 16. So even this is what is 16. So if you do your computation, your final response will be 1.96 meter per second square. So therefore, acceleration due to accelerations or gravity on the moon surface because of the space, you can say that the gravity on the moon surface, best way, let me write it here. I have enough space. So you see how physics problems are a little bit challenging, right? So you have to study hard, you have to do a lot of practice, you have to solve many problems as well as you can for you to be competent in advanced physics. So therefore we say that the acceleration due to gravity on the moon surface is 1.96 meter per second square. So please tell me in the comment sections if you've got it. If you didn't get it, do the corrections. If you got it, congratulations. Didn't get it, don't worry. Best way of learning physics is learning by mistakes before the exam. Doing mistakes before the exam. This is example 4. The mass of the Jupiter say Jupiter. Do you remember Jupiter? It's the largest planet. It's the largest planet. Is 1.9 exponential 7 kilogram. And that of the S out of the S, that of the Sun, out of the Sun is 1.9 exponent 30 kilogram. The mean distance of the Jupiter mean distance of the Jupiter mean distance of the Jupiter from the Sun is 7.8 exponent 11 meter. Question now, calculate the gravitational force which the Sun exerts on the Jupiter. From the Jupiter, assuming that Jupiter moves in a circular orbit. Assuming that Jupiter moves in a circular orbit. In a circular orbit. The circular orbit around the Sun. Around the Sun, calculate the speed of the Jupiter. Calculate the speed of what? Of the Jupiter. Calculate the speed of 40 of the Jupiter. So, copy the question, and hence I'll clarify or explain it when you enjoy the beauty of physics. The question said that the mass of the Jupiter, the largest planet, is what? 1.9 x for 27 kilograms. It's heavier than the Earth. The mean distance of Jupiter from the Sun is 7.8 exponent 11 meters. Calculate the gravitational force which the Sun exerts on the Jupiter, assuming that the Jupiter moves in a circular orbit around the Sun. Calculate the speed of the Jupiter. So how many questions do we have there? 2 questions. Number 1, we have to calculate what the gravitational force. Number 2, you have to calculate, because I've got the questions, you have to calculate this gravitational force. And then number 2, we have to calculate what the speed. So some of the information about the speed are there in the next sentence. Assuming that the Jupiter moves in a circular orbit around the Sun, then calculate the speed of the Jupiter. Not the period, the speed of the Jupiter. You want to try? It's a little bit concepty because it's demanding on another topic of mechanics. So let us check the data that will be given. What are we missing so we can find them quickly as well as we can. The first states that the mass of the Jupiter being given is 22, 1.9, so 27 kilograms. The mass of the Sun is 1.99, 30. Mass of the Sun, which you call the MS, is equal to 1.9 exponent 30 kilograms. So before we go for the speed, those are the details, then we have to find gravitational force. Gravitational force. How do you find this gravitational force? That's the question. Which exerts on the Jupiter. This is the first state. Those are the data that we have been given, so we have to use them effectively in order to find what we have been asked to find. The second state now is this. We have a planet revolving around the Sun. The name of this planet is what? Is Jupiter. So always in case of physics, especially for the gravitational problems, whenever we given some questions, the best way is to draw it. Draw out a sketch, mean that is sketched. Sketch the orbit. Sketch the orbit, or sketch the orbit of 40 of the Jupiter. Around what? Sketch the orbit of the Jupiter around or revolving, not around. Revolving. Revolving what? Revolving the Sun. At a distance, it means that we have this distance also. Yes, I forgot. So in the case of the data, we have also distance, which is out of the Jupiter, is equal to 7.8 exponent 11. Okay? So to sketch this phenomena, okay, so this the sun, suppose that one of 4 keys and one of its 4 key. And then this is a body of mass M. Here we have radius of the Jupiter to the Sun. Okay, so this is the planet Jupiter. Jupiter. And this Jupiter has its own mass, we call the mass of the Jupiter. We give us in the problem. Alright? So if this is the case, we say that we go for the steady state. The steady state, we say that Jupiter and Sun attracts each other. Sun attracts what? Attracts each other. Is the force that we call it Newton's universal law of gravitation. So if they attract each other now, we say that because the questions ask us, find that force of attraction. So it's a force of attractions according to the Newton's law of universal gravitation. We say that in her, the force of attractions between the two bodies in the universe is then proportional to the products of the air mass, and inversely proportional to what? To the mean distance of the Jupiter to the Sun. So this is what we call mean distance from the Sun, from the Sun to the Jupiter, from the Sun to the Jupiter. That is all about force of what? So if this is the case now, we say that the force of attractions between the Sun, because this is a mass also, the mass of the Sun, MS, yes, it is there. So you have been given some other constants, but other cannot be given. So from there you have to answer the concept that you know, and then just leave the rest. So it is the force of attraction between the Sun and the Jupiter. So Jupiter Sun, GS, is equal to what? Is equal to gravitational constant, mass of the Sun, mass of the Jupiter, over radius of Jupiter, square. According to the data being given, everything is there. Right? So the universal gravitational constant, okay, it's not even mentioned, but we know this value for this case. Mass of the Sun is known, so G is 6.67. Right? Mass of the Sun is equal to what? Mass of the Sun 30 kilograms. Multiplied by the mass of the Jupiter, which is 1.9 exponential from 7 divided by radius of the Sun, which it is what? 7.8 exponential 11, very far square. So you can use your scientific calculator now to compute the response, which it will be the answer for the gravitational force. Gravitational force. Gravitational force between those two points. Please use your scientific calculator. In case you don't have any scientific calculator, please look the descriptions of this video. You will see how will you get it, and I will shape it for you. So when you do your computation, all in all, you find gravitational force is 4.147 exponential 3. 4.14 gravitational constant or gravitational force is 4 4.147 4.14 exponential. Say it is exponentially 20 Newton. Very huge force. That's the gravitational force between Jupiter and what? And S. 4.147 exponential 3 Newton. Right? That was Roman A. Have a Roman B now. Can you try? Calculate the speed of the Jupiter.